Hey folks, I'm Professor Amy Gates, and this video is going to focus on how to convert data that is in a text type format into a data frame using Python's CountVectorizer method. So here you can see that I'm inside Anaconda's Spider IDE, and we're going to go through 3 examples to look at what text data can look like when it's stored in files or as what's called a content list. We're going to talk about what a corpus is, and we're going to look at 3 examples of how to read data from a corpus essentially, or from content, into Python, and then use CountVectorizer to vectorize that data. So as a quick reminder, CountVectorizer is an sklearn method that allows you to essentially take any text, so anything made up of words, and it doesn't have to be individual words, but this one will focus on looking at each token as an individual word. And you can create a data frame such that each word is a column name, a variable, and each document is a row. And what you'll have inside that data frame are essentially counts or frequencies of the entire vocabulary. So let's look at examples which tend to make more sense than just explaining it randomly. So first, let's say you were going to use CountVectorizer on your own and you had never used it before. Maybe you heard about it, you found it by Googling, but you weren't sure how to import it or what to do. So one of the best ways to remedy that is if you go to sklearn, which is short, by the way, for scikit-learn, and you type in CountVectorizer, you'll come to a page that looks like this. Whenever you see this, what this is telling you is that if you copy this initial portion, so sklearn.feature_extraction.txt, and you paste that into the from area. So from here, you want to import CountVectorizer. And that's how all of these work. And so that's where this line of code comes from. And what's great about that is sklearn is filled with so many different machine learning options as well as text mining options. Once you understand how to use them, they all essentially work very similarly. The other benefit of understanding these pages is it shows you the parameters that are necessary for using something like CountVectorizer. For example, in this case, one of the parameters is called input. And if you'll allow me to scroll down briefly, although I will go through this entire line of code, you'll notice that when I use CountVectorizer, I have a parameter in here called input. And that comes directly from the requirement, the parameter requirement of CountVectorizer. So that's not just some word that we're using, that's actually the name of one of the parameters. And you can see all the parameters up here. So input, and the default means that if you don't put anything for input, it's automatically sent to content. There is a parameter called encoding, which if you don't put anything for that, it's automatically set to UTF-8. And so on and so forth. So it shows you all the parameters and their defaults, which is great because in most cases, you don't actually need very many of the parameters. And here, even though I didn't have to do that, I'm doing it anyway so that you can see it more explicitly. So this is the perfect way to learn not only about CountVectorizer and how to read it into your program, but the names of the parameters. And then finally, what values those parameters can take on. So for example, the input parameter is one of the most important parameters. If the input parameter is set to file name, then your program or Python, or really I should say the CountVectorizer method, is expecting you to pass it a sequence or a list of file names. So that's the key there. So if you set input equals file name as one of your parameters, which I did up here, then when you use CountVectorizer, it expects you to give it a list of file names. And when I do this, I use a complete path. so that no matter where I run this code, my computer always knows where the files are. And I'll show you an example of that. I'm not going to use file in my example, so I'm going to skip it, but it is an option and you can read about it later. The other option that's very common is to set input equal to content. So you can see in my code here that I have input equals file name for the first example and input equals content for the second example. We're going to see how both of these work. If you use content as your input parameter, it actually expects you to have a sequence of items that are a string. So that actually looks like this. And you can do this in a CSV file and a text file. It doesn't have to be hard coded in. In fact, it never is. It just is for this example to keep it simple. So content literally expects text content. File name literally expects a list of paths to file names. This file name is called t1.txt. Here's another one, t2.txt, and so on. So it's very, very important when you learn anything new like CountVectorizer to come here and read about what the parameters are, what they can be set equal to, what that means, and so on. Some of these more advanced parameters we're not going to go through in this video, but you might want to check out stop words, which enables you to remove words like and, if, the, this type of thing, and so on and so forth. So there's some really great parameters, max features, grabbing the vocabulary, so on. All of that can be learned here. But let's do first things first. Let's go back to the code and go back to the beginning and just understand what we're trying to do here. So in addition to bringing in CountVectorizer from sklearn's feature extraction.txt, I'm also bringing in pandas, and I'm nicknaming it PD, and I'm bringing in OS, which stands for operating system, and you'll see why I'm going to do that in a second. In order to use this code, you have to create on your own computer a new folder. Make sure you know where you put it. Inside that folder, you're going to create 3 small text documents. I named mine T1, T2, and T3. And so you can see that here. Once you create these 3 small text documents, you want to put a little bit of content into them and keep it really simple. Let me show you an example of that. So we are looking for, let's go into here just real quick for a second. So you can go onto your computer anywhere, into any area, and you can create a new folder. So let me just do that. Let me come in here and let's just create a new folder. And I can name that folder anything I want. I'll just name it My Corpus, just as an example. A corpus is a collection of text files. That's what it stands for. So inside of My Corpus, now I have an empty folder. It's really important to use an empty folder for your corpus because if you have anything in there or anything hidden in there, your code may not work right. It won't be able to read the data in the corpus properly. Once you create that folder, make sure you know where it is. So where is this folder? It's here in this path. It's in C, users, prof A, my documents, Python scripts, text mining, and so on my computer. On your computer, it's in your path. Once I'm in here, I can create text documents. So let's get down here and just create a plain old text document. And this one you can just call T1. And let's open that text document and just put some stuff in it. So inside of here, I could put, this is a text document. My text document is cool. And then I can save it and close it. And now I have a text document. If I open that text document back up, you can see that we have text in our text document. Each one of these words is considered a token using CountVectorizer. And what it's going to do is it's going to break this down into its individual tokens like this, and is, and a, and text, and document, and my, and cool. Those are going to be the words. And then it's going to start to build up your vocabulary. So if I were to create another text document, and instead of building them all up, because I have a whole bunch, let's take a look here. Oops, I don't have any in there. Let's take a look here. I can create as many text documents as I want. So in this one, I have this is doc 2. Doc, and let's take the S away. Doc 2 is the second doc, right? Okay, we'll get back to plurals and all that stuff later. All right, what's in T3? Well, kind of the same idea. Here is document 3. Why are these so tiny? Because I want to show this example as a very tiny example just to make sure that it works. You want to make sure that the code works, that your logic works, that your algorithms work. Once you know that you can do it for this, you could do it for 1,000,000 documents, and you can do it for very complex documents as well, like positive reviews, such as something like this. This is a positive movie review. It's very, very long. So once you can get it to work for one thing, you can get it to work for pretty much anything you want. And that's our goal. So starting small. All right, so in order to use this code, make sure you have the folder, you put some text docs in there, and you know the location of your folder. So we're going to now do 3 different examples. In the first example, I'm going to do what's called hard coding. That's where I actually create the list by hand. I say, well, my list, and as you can see, I have square brackets, which means it's a Python list. My list contains this complete path to my first text document inside my corpus. Here's my second text document inside my corpus, and so on. You can already imagine that if I had 1,000,000 text documents in my corpus, this would be very unpleasant to type in, right? Even if I was cutting and pasting. So this is a horrible way to do this, but it's a great way to make sure it works. So this is our first example. We're going to use this, and we're going to use CountVectorizer with input equals file name, because when you have input equals file name as a parameter, it expects a list of files. And that's exactly what we have here. In the second example we're going to look at, I have a list of content, and you can see that it's multiple content. So here's the first document. This document could be an entire novel, or it could be a tweet, or it could be a restaurant review. It could be anything. It's just really tiny because we want to keep this small. So here's one document. Here's another document. And here's a third document. So in this example, my content list is a list of content in the documents, whereas my original list up here is a list of file names where there is content in my corpus. So those are 2 different things, and we're going to need to use 2 different input parameter options in CountVectorizer to work with these 2 different things. Now, as I noted before, both of these methods are horrible, right? You don't want to start typing things or hard coding things in. But why do we do this? Because we want to make sure that it works. Because once I can get it to work like this, then I know I can read it out of a CSV file. And once I get it to work like this, then I know I can use operating system methods to read it directly from my computer. And that's precisely what we're going to do in the final example, where instead of hard coding, we're actually going to use the operating system, and we're going to get all of the files from our corpus, and we're going to build the list of files. So essentially, we're going to build this on the fly. That means that if there were 10,000 text files in here, no problem, because we're going to build this up. And the number of files won't matter anymore. And that's what we're going to do here. So 3 examples to go through. Let's get started with the first one. So in the first example, we know that we're going to use CountVectorizer. Because we're using CountVectorizer, and we know from reading the documentation that we need to specify our input parameter and then any other parameters or variables that we want. Now, let me explain something about sklearn methods and functions, which is what CountVectorizer is. In sklearn, using something like CountVectorizer, you first have to instantiate it. What that means is you build one of your own. So it's kind of like buying a car. When you go to a car dealership, you don't say, I want the car. You don't get the car. There's many cars, there's many versions, there's many colors, which are parameters. You can have 2 doors or 4 doors, you can have automatic or you can have stick. There's parameters to cars, just like there are to functions. So when I instantiate this, what I'm saying is I want my very own CountVectorizer function. And I want it, I want it in blue with racing stripes, right? Okay, I know, long story. But in this case, I want the input parameter to my CountVectorizer to be file name. Don't you hate pop-ups? I kind of hate them a little. And I want the stop words to just be English stop words. So it's going to automatically take out things like and, a, the, it. And if you want the whole list, you can find that on sklearn. When I create this for myself, when I buy my own car, I want to give it a name. So I'm going to name it my CV1. So when I run this line of code, it builds me my own CountVectorizer object, if you will, and it's called my CV1. So later, I can use my CV1 and methods of my CountVectorizer, of CountVectorizer, I should say, like fit transform, to create the data frame that I'm trying to create. Okay, so let's make sure this all makes sense. In order to use input equals file name, I need to have a list of, in this case, complete paths to my files. And that's exactly what I have here. I do this in a corpus so that inside this corpus, which is just a folder on my computer, I'm positive that only these text files are there and no other junk or stuff is in there that will confuse Python or CountVectorizer. Let's start running stuff. So let's highlight this first and let's just run this block of code so that Python is aware that my list now stands for these 3 files on my computer which have text in them. We don't need to run this yet because we're not going to use that yet. Now, let's run this line of code where I create my own instance of CountVectorizer, like buying a car, not the car, and I name it my CV1. So let's run that as well. So now Python knows that I have a CountVectorizer object called my CV1 that I can use to do CountVectorizer stuff. All right, cool. So now what can I do with that? Well, I have to do a few steps. So let's think about my goal. My eventual goal is to build a data frame where all of the words in all of these text files are the column names. So every possible word in T1, T2, and T3 all together become my vocabulary. The stop words are taken out, and what's left is what becomes my final vocabulary. And each word in that final vocabulary should be a column in my data frame, a column name. Each row in my data frame represents a text document. So I'm going to have 3 rows in this data frame, and I'm going to have as many words as is in my final vocabulary as columns. How do I make it do that? Well, there's 3 steps. The first step is using my version of CountVectorizer, which is called my CV1. I'm going to call a method called fit_transform. Now, what does fit transform expect? It expects a list of complete paths to files. Yes, you can use relative paths. I don't cover that, but for those of you who understand what I just said, you'll know how to do that. I always use complete paths because otherwise things get lost places and it's a pain in the butt. What is my list? My list is precisely a list of complete paths to file names. Why is it that fit transform expects this? Because my CV1 was initialized, instantiated, using input equals file name. And when I use input equals file name, and then I call fit transform, it expects a list of paths to my files. So it's all really important. Now I'm going to run this code. When I run this code, it actually it doesn't create the data frame yet. It actually creates a sort of matrix object. It's a document term matrix object. You can print the data type of it if you want, if you're curious to see the data type. Sparse matrix is the exact Python data type of this object. There might be cases where you want to keep it as a sparse matrix to do other things. That's fine. But in this example, I want to convert it to a data frame, so that's where I'm headed. In order to get it to be that final data frame, I need a couple more steps. So now that I have my document term matrix object, which I've named mymat for my matrix, now I need to get all of the vocab. So what do I mean by that? What's all the vocab or vocabulary? All the vocabulary is all of the possible words in every single document I have. So if I had 100,000 documents here, the vocabulary would be every single word in every single document except the stop words. So it could be tens of thousands, right? So I can take my CountVectorizer object that I built up here, and I can run another method on it called getFeatureNames. What getFeatureNames does is it gets all the vocabulary, which is actually really useful. Be careful printing that out if you have tens of thousands. So let's run this line of code. Now we have all of our vocabulary in a variable called myCols for my columns, because each vocabulary word is going to be a column. Let's see what that looks like. Let's print that out. Here's our vocab. It's just doc, document, fun, and second. Well, you might be thinking, I don't know. Is that really true? I mean, is that the entire vocabulary? Let's find out. Let's go to pretend Corpus. Do you guys hate Windows 10 search? Like, I know there's pretend Corpus on my computer, but it won't show it to me right now for some reason. Probably because I'm making this recording. I'll find it myself. So here we go. Let's go to pretend Corpus and go inside. I know there's 4. I added one the other day. Doesn't matter. And let's take a look. So this actually looks pretty accurate. We don't have a lot of words in here. So we said one of the vocabulary words was doc, one was document, fun, and second. So we see fun here. We see doc. All right, why isn't this down here, or is, or the number 1? The answer to that is CountVectorizer automatically removes numbers. It automatically removes punctuation. It automatically makes everything lowercase. And it automatically, in our case, because we asked it to, it takes out stop words. This is a stop word, is a stop word, and so on. That looks good. Let's look at T2. Here we go again. We have doc. We have second. That showed up here. So this looks good. Okay, just ignore that. I'm in a city. Okay, so let's keep going. What we know right now is that this has worked. So what we did is we used the getFeatureNames method, and that got us all the vocabulary that was in our 3 documents. Now you can imagine that if you were using 100,000 documents, this list would have tens of thousands of words in it. That's okay. That's why we keep this example super small. All right, so we're halfway there really. We have all of our column names. And we've saved our column names as myCols. Here they are. Here's our column names. What do we need to do now? Now we get to finally make the data frame. So we're going to make the data frame using pandas, which we abbreviated as PD. Now let's get up here and remind ourselves that when we imported pandas, we imported it with the nickname PD. So down here, when I say pd.dataframe, I'm saying use pandas and let's build a data frame. So what does the data frame method or function expect? Well, it expects some kind of array, and I'll explain that in a second. And it expects you to tell it the names of the columns. So you want columns equals, you have to type that in, it has to be exactly that. And then whatever your column names are. Well, how do I know my column names? I just grabbed them by using the Get Feature Names option for my CountVectorizer. Now, what the heck does this mean? So in this case, remember that my mat was my original matrix, my document term matrix that I created using my CountVectorizer and using the fit transform method on my list of files. So that was that document term matrix that I built. Now, in order for me to convert it to a data frame, I have to take that document term matrix called mymat, and I have to convert it to an array. So I can do that simply by doing dot to array parenthesis. That applies the to array function to the matrix, and it's not, I don't have time to talk about that now, but you can just Google it and see what to array does. It's very straightforward. Let's do that. And now let's print the data frame. So I'm going to save this in a variable called mydf for my data frame. Let's see if all the work we just put in created a data frame. Let's see if it did what we wanted to do. And it did. There it is. And let me scooch this up a little higher so we can talk about it. Here's our data frame. Each word is a column name or a variable. We had 3 documents, T1, T2, and T3. Here they are. First document, second document, third document. And what do the numbers mean in the data frame? They're exactly the number of times each word occurs in that document. So let's look at the first document. Let's prove to ourselves that that's actually true. Always prove to yourself that what's going on is actually true. Let's see if it'll allow me to find something on my computer for a second. My computer is mental. Okay, let's open that up. Okay, so let's go into pretend Corpus and let's go into the first document, which was T1. Let's make that a little smaller. Let's have a look. So is it true that the word doc occurred twice? 1, 2. So yeah, it did. What about the word document? Is it true that that occurred no times at all? Yep, I don't see the word document anywhere here, so that's correct. What about the word fun? Did that occur once? Yep, here it is. And what about the word second? Is that in here anywhere? Nope. So this is exactly correct. What it did was it took every possible word in the entire vocabulary and it asked the question, how many times did each word occur in the first document? And it wrote down, well, it didn't write it down, right? It just did what it did, but it gave you the frequency. So that's pretty awesome. And we can do the same thing for T2. I won't go through it, but let's just do DOC. Occurred once, twice, 3 times. Yeah? How about the word second? It's here once. So there's that 1. Why do I go through all this? Why am I taking the time to confirm? Because I know now that it's doing it right. It's doing what I expect. That's really important when you write code. Keep it tiny and check what happens so that it does what you think it should be doing. Because you know what? Sometimes it doesn't. Okay, so what did we just do? We just built a data frame. Why is this awesome? Because now we can use all the different machine learning techniques. We do not have labeled data here. So we cannot do supervised learning on this, plus it's way too tiny. But you know what we can do? Clustering. This is a vector. It's a 4-dimensional vector, 2, 0, 1, 0. This is a 4-dimensional vector, 3, 0, 0, 1. I can use Euclidean distance to find the distance between this vector, or the first document, and this vector, which is the second document. So I can tell you the Euclidean distance between 2 documents. Does that actually work? Yeah, believe it or not, distance metrics, cosine similarity does a lot better with high-dimensional data, can actually differentiate between documents and can tell you, for example, who the author might be. But that's a different video. If this data were labeled, if we added a label column and we knew the label or category of each one and we had a lot more data, we could then apply other machine learning techniques that were supervised. So this is the reason that we vectorize our text data into data frames so that we can then use those data frames to perform machine learning methods and techniques. Let's do example 2 now. So in example 2, we're going to use CountVectorizer again. But instead of using input equals file name like we did in example 1, we're going to use input equals content. And in this case, because we're using input equals content, when we finally utilize this, it's going to expect content, direct text, not file names. So in this case, let's tell Python that my content list are these 3 documents. Here's the first document, the second document, the third document. Let's run that. All right, so now Python knows we have a content list that contains 3 documents, very tiny. Now let's instantiate a CountVectorizer object where input is content and we remove English stop words, and let's call it myCV2. So let's run that line of code. All right, now we're ready to use it. So let's scroll down here where we're using myCV2. Same 3 steps. That's what's awesome. So first, we're going to use myCV2 fit transform. But in this case, fit transform expects a list of content because we built our CountVectorizer with input equals content. So now I have to give it a list of content, not a list of files. These are critical differences that are very important. When I run this line of code, though, it does the same thing. It's going to build me a document term matrix. Here's my sparse matrix. Same idea for the next step. I'm going to take that same CountVectorizer that I made up here, and I'm going to use the getFeaturesName method to get all the vocabulary words. Let's do that. Here's our vocab. Let's see if it's true. Remember, it took out the stop word, so it says our vocabulary is the word document. Yeah, there's document. It says we've got the word like in there. Let's see, where's like? Like is here, okay. It's got the word novel in there. Let's look for novel. There it is, and so on. So it's created a vocabulary, every possible word in these 3 documents, minus the stop words. Now we're going to build the data frame. We're going to take our document term matrix that we built using fit transform and convert it to an array. We're going to set our columns equals, just like we did up here, to our vocabulary, which we just got using getFeatureNames and is right here. Then we're going to use our pandas data frame method, and we're going to build a data frame called mydf2. Let's print that out. There it is. So again, notice that every word in the vocabulary is now the name of a column. And all the numbers here are how many times each of these words occurred in each of the 3 documents. Let's make sure we believe it. Here's document 1. So the word document is in there once, so that checks out. The word like, I don't see the word like in there, so 0 times. Novel, nope, that's not in there. Review's not in there, but the word text should be in there. Here it is. And the word website is not in there. Just like our first example, this is a numeric vector. It's a 6-dimensional vector. I can still use distance measures to measure the distance between this vector and this vector. I can use Minkowski, I can use Mahalanobis, I can use Euclidean, I can use cosine similarity, right? I can use any numeric distance metric to find the distance between this document and this document. Why does that matter? Well, it tells me how similar they are, and I might want to see if the documents cluster, or if I can predict who wrote a document, or some other factor that I want to predict. So far, excuse me, we've done two examples. They're both hard-coded in, but you get the picture. If we have a list, however we create this list, if we can create a list of paths to file names, we can use CountVectorizer with input equals file name, and then we can go through these three steps to build our data frame. First fit transform, then get your column names, then convert it to a data frame using pandas. Don't forget the array part. Same thing here. If we have any way we do this, we can build this list any way we want. We don't have to hard code it. If we have a list of content, we can use CountVectorizer with input as content, and we can go through these three steps, same three steps, to build that data frame. So let's see how this might look if we don't hard code it in. So in this case, I am telling Python that I have a complete path. This is on my computer, not yours. So you'd want to change this line of code to whatever your complete path is to your corpus. My corpus contains text documents, as we saw. I'm naming this with the variable path to my corpus so that Python knows that that's where my corpus is. Let's run that line. So Python's like, okay, cool, that's fine. All right, now let's look at this next line of code. Very fun and interesting. Notice the OS. Where did that come from? Remember we read in or imported OS, which stands for operating system? So because we imported operating system methods and functions, one of the methods and functions of our operating system is to list all the files in a folder. That method is called listdir, and it literally will give you a list of all of the files in any folder you give it. Now, what folder am I giving it? I'm giving it the path to my corpus. So I'm literally giving it this entire path, which is to a folder. Now that it knows pretend corpus is my folder, it's going to list all the files in there and put them in a variable called my file names. Let's try it. And let's print it out. There they are, T1, T2, T3, and T4. Remember that, in fact, inside pretend corpus, we actually have 4 files. So when we just do a full list of all the files in pretend corpus, we get all 4 of them. If we had 1,000 in here, we get all 1,000, and so on and so forth. So be careful what you print. All right, well, that's awesome, but we need to take another couple of steps. We know that in order to use CountVectorizer with input equals file name, which is what we're trying to do here, we want to use CountVectorizer with input equals file name. So that's this one. In order to use this, I need to create a list of complete paths to my files. Now I know my file names, right? Because I just used the operating system to store them in a variable called my file name. So I have all of my file names, even if there were thousands. They're all stored in a variable called my file names. You should test this by adding a few more files to your corpus, run this again, and see that no matter how many files you put in there, my file names always contains all of them. Why prove stuff like that to yourself? Because then you know what's going on, and you're kind of the boss instead of Python being the boss, which can be very dangerous. Well, if I know that I need a list, I better build one. To build a list, I'm going to make an empty list first. You can do that really easily in Python by creating any variable name you want, my new list, setting it equal to 2 square brackets that are empty. So let's run that. That just tells Python, all right, I have a new list. Nothing's in it yet. What do I want in this list? Well, actually, I want something that looks like this, don't I? I want this list to contain complete paths to all my file names, including T4. I want to build this on the fly, no matter how many files are in my corpus. How do I do that? Well, I'm going to do it with a loop. I want to loop through every file name that the operating system finds in my corpus. So it doesn't matter if there's 1,000 or 1,000,000. I want to loop through every one. So I'm going to use a for loop. This is a variable name. So the word next file name is a name I made up. I could have called this X. I could have called it Bob. None of those make sense, and it makes more sense to call it next file name. So for next file name in my file names, that's a variable. What are my file names? These, T1, T2, T3, and T4. Those are the names of the files in my corpus, which is up here, right? Now let's say you're like, I don't know, I don't believe you. Okay, come down here and just print next file name. And just run this one time, just like that. Just highlight it and press run. It found them. So it went through every single file in my file names, and each time it did it, next file name was set equal to the next name in my files. That's how for loops work. So the first time this runs, next file name is the first file in here, which is t1.txt. The second time the for loop runs, next file name is t2. The third time it runs, next file name is t3, and so on. The beauty of this is that it doesn't matter how many files are in there. It's going to scroll through them all and do whatever I want with them. Cool. Okay. What do I want to do with them? Well, I want to build this. I have an empty list, and into this empty list, I want to place this complete path, which is where the files live, and I want to append onto it each file name. In other words, I want the very first thing in this list to look like this, t1.txt, comma. That's what I want to be in here first. So I want the whole path, which I have up here. It's called, hang on, let me scoot you back over. It's called path to my corpus. I want that whole path, but on the end of it, I also want each of these file names. And I want this for T1, T2, T3, T4, and however many there are. That's what I'm trying to get it to do automatically. So let's do that. I know this is going to scroll through every one of these files, however many there are. Well, I want to take this entire path name, so that's this guy right here. That's the name of this guy. So I want to take that path, and I want to concatenate to it. The plus means concatenate. I want to tack on or concatenate 2 slashes. Why do I use 2 slashes? Well, you don't have to use 2 slashes in this direction. You can use one going the other way. If you have a PC, your options are 2 slashes this way or 1 the other. If you have an Apple computer, you have to figure out your slashes. There are options. Does this matter? Yeah, it matters. How did I figure this out? I tried a couple things. You don't wake up in the morning knowing about 2 slashes. Okay, so I'm going to concatenate these slashes on, right? Because I want it to go like this and then to say t1.txt, right? This is what I want. So I need first to add on that and then to add on that, right? That's what I'm trying to build into my list. That's what I'm doing here. I'm saying take that path, add on the slashes, and then add on the file name. Let's see if that works. Let's just run the for loop where I build each one and then just print it out. There they are. It worked for all of them. So I concatenated on. I know you're saying, where's the other slash? It's a dereferencer. We won't go into that. But it added all the, here's T1, here's the second one for T2, the third one for T3, and so on. So it did what I wanted it to do. It made complete paths, including the file name. Why go through all this trouble? because now I can have any path to any corpus, and this code will run. I just have to update where that corpus is located. And I can have any number of files in my corpus. So all of a sudden, this code runs for a lot of cases now, not just one. Now, finally, I said I wanted to build a list of these. In order to do that, every single time I build one of them, because I build one every time I go through the loop, right? So the very first time I go through the loop, I build this one. The second time I go through the loop, I build this one, and so on. Well, I better keep them. Otherwise, they're just going to disappear, and I'll just build the next one. How do I keep them? How do I put them in my list? I use append. Hang on, I have to take a drink. I need to drink water while I'm lecturing, otherwise I'll lose my voice. Sorry about that. So, if I take my empty list and I append or tack on each one of the file paths that I build through this loop, at the end, my list is going to contain all of them. So let's run it all now and see if that's true. Let's blank that out and run it all. There it is. And so you can see that here is my list. You can tell because I have a square bracket here and a square bracket here. Why is this here? Because we didn't comment out our print statement. It's still there. If I commented out that print statement and ran this again, you would just see the list that we built. There it is. So in this list is a complete path to T1, a complete path to T2, and so on and so forth. So this is awesome because now we just built the file list that we need to use CountVectorizer. Okay, so now let's use it. We're going to use my CV1 because remember my CV1 was the CountVectorizer that expected input equals file name, which means it expects a list of file names. Well, that's what we just spent the last 15 minutes building, so we want to make sure we're using the right CountVectorizer. So we're going to use my CV1 and fit transform, and we're going to give it that list that we just built. All right, let's do that. Okay, made us a sparse matrix, document term matrix. Let's get the column names, same 3 steps, right? Same 3 steps every time. Here's all of the column names. How come that docs is there all of a sudden? Well, it's there because this one included something the other one didn't. It included T4. And what's in T4? The word docs. So that's correct. And we're glad we checked that. Last step, build that data frame. And there it is. And we can do this no matter how many files we have in here. And no matter what the name of our corpus is. So let's try something right on the fly, right in the middle of nowhere. Let's go into what's in NEG. We've got some N's in here. Let's see what's in these guys. Wow, that's a lot of text. All right, good. So let's grab that path. That one is an NEG instead of a corpus. So let's make some, oops, wrong thing. There we go. Let's make some updates. Let's do this all over again, but let's just wing it with something else. Instead of pretend corpus as being the corpus we're going to use, let's comment that out and let's use NEG. We saw what was in NEG. It was a bunch of negative movie reviews, okay? Now, all this stays the same, right? It's just a different corpus. It's still going to list all the files in there. It's still going to make a list of complete paths. It's still going to build the data frame, and it's still going to print it out. Well, gosh, let's hope that works, right? So let's read this into Python first, make sure it can find it, it's comfortable with it, okay? Let's see if it sees what we hope it sees. Let's see if it sees the files that are in that negative. Yeah, N1, N2, N3, N4, N5. It found them. Let's build the new list and create that list of file names. There it is, it did it. So that's n1.txt, n2.txt, and so on. Let's take those 3 steps, same 3 steps every time, and let's build that data frame. Oops, we do not want to print the vocabulary. Hang on. I'm going to comment this out. Why don't we want to print the vocabulary? Because it's huge. You can print it if you want later, but I'm not going to print it now. Now let's run it. Beautiful. Let's make this bigger so you can see it. There's our data frame. So it didn't matter what data frame or what corpus I used. It didn't matter the size of the docs that were in it or how many. This code runs for any corpus. That's the beauty of writing code that is dynamic rather than hard-coded. Now, before I stop this video, I want to make a couple more comments. The first one is this data frame is probably not done yet for any kind of analysis. First of all, we've got numbers in here that CountVectorizer didn't remove for whatever reason. It does that sometimes. I've at least noticed that. That means that you have to go through code to go through these columns and remove any columns where the column name is a number. That's just more coding. Maybe you want to keep some of them. That's up to you. Maybe you don't. In other words, you have to clean your data set further before you do analysis on it. Also, when you perform text mining, words like year and years, they're really the same word contextually. You don't want 2 columns like this, so you'd want to aggregate these. Add them together, so 1 and 0 is 1, 0 and 0 is 0, etc. 1 and 1 is 2, and just combine them. Or you can take the high road and use a stemmer or lemmatization. That's not part of this video, but it's the direction you would go in if you wanted to not have these being separate and just consolidate them into one aggregated column, which is important because it reduces the number of columns in your data set, which reduces the complexity, which is always a good idea. The last thing that I want to note here is that this concept, though not this method, because this method that I showed you, this code, this is for corpuses, right? This is for corpuses, this particular one. But let's say you had a CSV file that contained a bunch of content like this. You can almost imagine that you could do something similar, that you could write your own auto code that opens a CSV file and reads every line of that CSV file and builds a list of content out of that CSV file, and then you would use this version of CountVectorizer. There's no perfect solution to any problem you're working on. I mean, maybe that there was one here, and if so, you got lucky. The truth is the concepts are what is important, and you still have to get your hands dirty when you code. Okay, so hopefully this was very helpful in understanding how to vectorize using CountVectorizer. I appreciate your time. Thank you for joining me.